Imagine descending to 90 feet in complete dark, and then finally turning on your lights or your laser, and then you're just surrounded by these animals.
These animals are Solmissus jellyfish, and the green light is coming from a device called SCUVA.
What it is essentially a video camera which you can see the diver holding, which happens to be me.
That's Caltech PhD student Kakani Katija.
Attached to it is a laser.
The laser isn't used to light up the jelly, but to illuminate the particles around the jellyfish.
Either small microplankton or just silt.
That's John DeBerry, Katija's mentor and the inventor of the device. He says lighting up the muck allows him to measure
the motion of particles within the water to infer the water motion itself.
And water motion reveals just how the jellyfish are propelling themselves along. DeBerry also uses fluorescent dye to shine light on jellyfish propulsion.
As the animal is periodically expanding and contracting its body, it's generating these vortex ring structures, and then as they're swimming, they almost push their bodies off of those rotating structures.
DeBerry's lab has invented all these techniques to uncover how animals maneuver in this aquatic environment. But their latest research builds upon this work and asks
how and whether these swimming animals might affect the large-scale ocean.
Specifically, do animals mix up the ocean by swimming in it? And about 50 years ago, Sir Charles Darwin, so that's this Darwin's grandson, this guy, had a theory about how animals might mix the sea.
Darwin's mechanism is similar to the idea of drafting.
He thought that animals mix the ocean by dragging water with them as they move. And to test this idea, DeBerry and Katija went to Palau, used the dye trick again, and this is what they saw.
There's regions of dye that continue to stay right behind the animal. So these animals, as they're moving through the water, they're drawing out these long fingers of this heavier, colder water into the water above.
And DeBerry says this water drafting happens with anything floating around in the sea, which suggests that mixing from animals has been vastly underestimated.
There were oceanographers who said because we didn't know how it was possible, that maybe it's just not possible at all. And we've, I think, demonstrated an answer.
And that answer is important because ocean mixing has an effect on temperature and CO2 sequestration, which means that predicting global climate may require understanding jellyfish. For Science Friday, I'm Flora Lichtman.